to do uh, good things. And I think that somehow worked, I guess. Thank you, Prasad, for that. So there are a lot of things is different nowadays, right? Today's topic is, of course, one of them. Thank you, Geography College, for inviting me as a resource person. Uh, why I'm saying this is important because, uh, what we do nowadays is not far from what's happening through the world. And there's this thing like if you don't update yourself or upgrade yourself, we are kind of like a computer nowadays, right? Every time you do something, you have to be you should try always to improve yourself. And this is something that with FDP, I think that's the logic, right? You are trying to improve yourself and bring the new, qualities and uh, experience with you, so that you can, impart those knowledge and ideas to your students, so they can do something better. So today's topic is something, the demystifying large language models and generative AI. This is don't worry about the topic. It could be something very complicated, but I will try to make it as easy as possible. But before I jump into the presentation, I have this habit. I really like physical presentation because I could see the faces of the audience if they are actually getting or not, and eh, with that I can adjust my talking. I could explain things. So if at least some of you could turn on the camera, it will be much easier for me to understand if you're at all getting anything. If not, of course, you
Yeah,
you
I
have your
request the participants to please on
yeah.
your video.
This is just my kind request. It's not at all you have to do it. You have your privacy concerns, I know, but this is just my request because it will be easier. Otherwise, I will be speaking to a black box and it doesn't look or sound right. I think that most of you are teachers, right? You understand what I'm talking about. If you don't see the faces of your student, it's really hard how to explain things, right? So I guess we have a lot of time, and I will try to make sure that everything is very slow and try to make you understand what I'm talking about. Uh, and before I jump into the actual topic, may I know like how many of you are familiar with this generative AI language models? If you are not familiar with it, have you used ChatGPT? I guess that's the most popular one, right? In some form, I guess most of you have used, or maybe you're planning to use, but you don't know how to use it, or something like that, right? So what I'm trying to teach you here, or at least give you the experience, is how you could use this kind of tool, and how these tools are actually being developed, and how you could, make something like that. Of course, it's not easy. It's resource heavy. You need a lot of training. You have to have a computational background, but it is possible. That's what I am trying to show you. And if you are not planning to develop one, at least you know how to use it, and that's kind of the logic here. And I think if I'm correct, all the schedule that I have seen for FDP, there are a lot of people who are going to introduce you to this kind of topic, how you could use it as a teaching tool, how you could use it as a research tool. So this might be it. So what all of the research person is trying to tell you, at least to start using this kind of tool, because you will find it very interesting. It doesn't matter what kind of topic you're working on. It doesn't have to be computer science. It doesn't have to be, mathematics or physics or anything about science. It could be completely like literature, history, anything that you are working on. You can just, choose. Okay, this is something I will use. It doesn't matter how good I am with computers, because these models are extremely smart uh, to help you, and to help you to teach the student. Just one request: if you have some questions, just ask. It doesn't matter. You can stop me at any point. If it is too difficult, you can also tell me. I will try my best to, bring the level of complexity as low as possible, because that's the whole point. If you don't get it, then I'm just speaking and you are just sitting in front of a screen 1.5 hours. So it doesn't make any sense. So okay, let's start. So if I start, this is
Yes,
me
sir.
in a
You can
nuts.
start.
Yeah, yeah. So this is me in a nutshell. So I work at IFA, Institute for Energy Technology. In a department called computational material processing, and it's a department that deals with everything, I would say. So we work with hydrogen technology, we work with solar technology, we work with wind technology. So everything related to energy. We work with nuclear energy. So a lot of things. But our approach is always about computational, like how could we do this modeling? The biggest difference between the modeling that I used to do at during my physics PhD time and what I am doing right now is the reality. Like when when you're doing PhD, you are focused, or at this moment as a faculty, so you have this. You also want to publish some papers, right? And that's your whole motive. So most of the papers that comes out of it is very theoretical, and you basically trying to enhance the knowledge of the community. Okay, I'm doing this, and you can do something like this. So you theorize something. Okay, this is possible, but things are different now. Things has to be more real. So how do you simulate things that is very practical, and can you improve the industry? So if suppose there is a wind tunnel, experiment, or windmills. Yeah, you might have seen windmills as well. Can you increase the efficiency? This kind of things are more important. Or you are dealing with solar panels. How do you increase the efficiency of solar panel? How do you increase the lifetime of the solar panel? Then suppose you are sending satellites to space. So can you, I know, accurately model this satellite so that it actually can behave the way you want, because these are like $1 million equipment you're sending to space. If something you don't plan accordingly, you don't test it out, then it will just go down in flames, and it's a huge monetary loss. And at the end of the day, most of the time, it's the taxpayers' money, so we have to be very careful about it. So this is main what we do right now uh, as a part of Institute for Energy Technology. And being in Norway, Norway is one of the beautiful places on Earth, with auroras and some nice natural views. And that's it. I will not to explain more. So a little bit introduction to the institute as well. So we deal with a lot of different topics. Why I'm showing this is, this is part of the process. Some of your faculty, and I know that some of you are researchers as well. So if you are interested in any of this topic, you might consider, something as a career. So these are all of the research areas that's currently very, very, active, and you could choose something that you might like, and you can develop your career on that. Or if you're a faculty, then the next thing is, these are the topic that's the world is doing a lot. So you could choose something and work on it, or teach your students. Okay, these are the career options you could say. So there are a lot. If you're interested, just contact me. I will just send you the information. That's one of the thing. So this is our main topic. So how these large language models work, that's quite important to understand. But this is very simple. People think, okay, it's a very complicated piece of coding. There are, and some of you have already heard, okay, it's about data. More the data the model has, then the better it will perform. Of course, that's true, but it's not entirely true. It's the algorithm, how these models can understand uh, the data. That's quite important, because there are a lot of research topics uh, on this kind of intelligence, computer intelligence or artificial intelligence. In the beginning, it was more like we're interested, if you have uh, ever encountered the chatbots, not the new generation chatbots, the old generation chatbots. Sometimes different websites used to offer this kind of chatbots where you could just write something and it will try to pitch the information for you. Okay, are you asking about this? This was to reduce the workload for this operators, like service operators. Suppose you want to complain about your Amazon delivery. So you want to call them and tell them, okay, I have received this package, but it's damaged or something like that, or maybe it's misplaced, or it's being delayed or something like that. So what you do, either you write an email or just call Amazon call center. So this was the standard norm. So you understand the amount of number of people usually buy things from Amazon. So if at least 1% of them are having problem and trying to contact, then it's a very difficult situation for the company, because either you have to employ a lot of people, like what we call customer service, or you have to find some solution that might reduce the workload. So this is one of the example how the companies are doing this, reducing the workload by using AI chatbots. That's one thing. So the chatbots are becoming much more, I would say, intelligent, because now they could answer your question even without human help. So how do they learn? This is one of the things. Other thing could be like, suppose if you're using ChatGPT or Anthropic or Perplexity, there are a lot of them, or Microsoft Copilot. Uh, so how this kind of model could answer your questions, how they know what you are asking, because this is a piece of computer code. It has no feelings or nothing, right? So everything started at a point where it called natural language processing, NLP. And then the whole whole idea about natural language processing was to let the computer understand what you're speaking, and how it could answer your question. Because when we speak something, it comes with emotion, and usually the computer can't understand the emotion. I think you might have encountered this problem with when you are chatting with someone. So if you're sending a message on text or WhatsApp, you're saying something, the other person is not understanding what you are saying, and there is this communication gap. And when you see that, okay, the other person is not getting it, what you're asking, so what you do, you just call them. Okay, I was not trying to say that, or I was not asking that, I was asking this. Can you please tell me? So this is about the emotion that you transfer while you are talking. So you have certain kind of, I think, the way you talk and something like that. But humans are, very smart, understanding emotion in general. That because we are being trained from childhood, right? If you see a small child, we basically try to teach them emotion first. So they try to learn how the parents are behaving around him or her. Suppose you're smiling, this small child will be smiling back, and that's where the training starts. You see something and you're trying to understand what is happening. So for computer, it's very different, right? Because how a computer could understand. So the computer scientist, and all of the scientists, I would say it's only computer scientists, because there are physicists, chemists, biologists, every one of them, they try to find out this whole new idea where the computer can have intelligence. So they coined the term when they actually invented something like that. It's called neurons, because that's what it is for the human. We have the more neural connections you have, the better you are to understand something, or and to remember something. So, and from the childhood, if you think about a small baby, the more you expose the baby to new things, they will have more neural connections. So that's how uh, it is. So they try to replicate the same idea. How it happens with a baby. Can we do the same thing with a computer? But of course, you need, human brains are very, very good at, processing things because it has an enormous amount of CPU or GPU, whatever you say. But for computers, it's limited because, of course, things are getting different now. Nowadays, we are getting computers. They're so powerful. Even you have everyone has a smartphone, and it's quite powerful compared to 10, 20 years back. So things are changing, and that's why we are going for smarter and smarter models, which can do.
Sir, your voice is not audible.
Just
Okay, now it is audible.
Uh, yeah. For some reason, my headphone was not responding. Okay, so that's something we are going to. But the problem was, with the NLP, natural language processing, it was you are reading through text. And when you're reading through text, that means you are reading one word at a time. And it takes a long time because if I give you a picture and I ask you, can you describe the picture? It takes quite a long time to explain everything that is happening in a picture. But you get it much faster when you're not describing, but when you're trying to understand from a picture. Suppose you were seeing a picture, a couple of birds flying, then you immediately know that, okay, yeah, I can see some birds flying. Then you can look into a deeper picture. Okay, what kind of birds they are, or where they are flying, something similar, or what is in the background. So this kind of things, like the minor details, you will see later on. So when you are we in general, we are looking at a picture, we are generally focusing some parts of it, and that's it. That was the idea that clicked to everyone. Okay, can we not process the entire text at a time, like one word at a time? We'll just try to understand the whole in a whole sentence as a picture, because pictures are faster. So here on this slide, you see there is a text on the one side and there is one picture. And the text actually tells you some instruction about a marathon race. And on the left-hand side, you see there are some people running marathon. They tell not entirely the same story, but something similar. So if you look at the left-hand side picture very carefully, you will see, okay, how can I differentiate this? I see that, okay, some people are running, they have a costume, and they have numbers taped on the chest. So from these three things, you can understand, okay, they are marathon runners, because I don't know anyone else or a group of people running together with a uniform. So that's your understanding from the past and what you see from the picture. So this is something. And this idea, well, we turned into something what we call AI, artificial intelligence, where it could understand what you are trying to teach or you're trying to understand, and it could use previous knowledge baked into this, and then it can tell you something. So this is what it is, like large language models and generative AI. So large language models, in short form, we also call it LLMs, where it's a part of foundation models. That means they are pre-trained. So there is like a base idea of knowledge, and then you add something on top of it. So you train this base model with specific skill set, and it becomes fine-tuned model. Earlier, what it was like one task, one model. That means in general, intelligence was very limited. So it could develop something like that, but it could only do one thing at a time. or like they are supposed to do only one thing. So we used to call it intelligent tool, but this is not. You can't entirely say this is intelligent, because intelligence means it should be able to do something more than one task, right? Otherwise, it's just a robot, and that's it. That's what it is, right? But after the development of large language models, and of course the concept of generative AI, we have started to change the world in a different way. We have started to look at the world in a different way. We are trying to find many ways uh, how to use it in real life. So where it started. So this is the paper. It's not that long ago when everything exploded. Like, so this is a paper. It's a research paper from Google. They actually they were the forefront of everything, the large language models and generative AIs and everything. But they were not actually doing so much because of the money required for such models, because you need huge computational resources. I Huge means it's not like it's completely impossible to think about how big it is, the amount of money that you need to train this kind of models. So uh, and before this idea of this particular idea that attention is all you need, it was very difficult. So this was the first paper that Google published, and from there everything exploded like crazy. And of course, then came the ChatGPT, the one that triggered everything. So this paper tells you one particular idea. The attention is all you need. Yes, that's actually very true. So I think being a teacher, you also are familiar with this idea. You'd always tell the students, okay, you have to pay attention what I'm speaking, or you have to pay attention what I'm teaching. Unless you pay attention, you don't learn. So that's very important, right? How And that's one of the thing you're trying to say from the beginning. So we wanted to find a way that would actually reduce the complexity but increase the efficiency. And when you pay attention to something, you learn fast. So that's the idea, you know. So this paper gave us the main, I would say, core component of this whole generative AI, LLMs, and everything. They're called transformers. So if you are fond of English movies, like basically sci-fi movies, now you might be familiar with the idea of transformers, but we are not talking about that transformer. Or the transformer word that you are familiar with is comes from the electric transformer as well, that you can find in your locality or neighborhood. Here it's a different kind of transformer. The transformer is kind of like a very specific algorithm baked into one particular object, where it has two different kinds of layer. One is encoder and one is decoder. Encoder is the way it tries to learn something, and decoder is when it basically use this knowledge into permanent storage, I would say. I'm just trying to use as simple explanation as possible. If there is some expert in the audience, you could just try to look more into it, because these are very deep understanding that you might want to learn explicitly. So, but if you have specific questions, feel free to ask. That's one thing, of course. So this is something, it's a very complex methodology compressed into one particular object. And that's the object we are talking about, this transformer. So it has two important components. One is attention and is learn. It's the same thing I'm all talking about. The way we deal with babies, the way babies deal with new information is the same thing that we do with large language models. So we wanted to teach the computer how, in general, humans learn about something. So we wanted the transformers to process the information, not one by one. That means it was usually when uh, it's a very early childhood. I think when we are introduced to texts, when we actually are capable of reading something, what we do, we try to go word by word. Like, okay, if I'm given to read some text, what I will do, I'll say, okay, the bag check will be located on Eastern Parkway between Franklin Avenue and Glasson Avenue. You will need to check your bag before you enter the start area security checkpoint on Glasson Avenue. So this is the way it happens, right? And for the computer as well, it was like that. And it takes so much time, even for the computers, because this is small text. So, and nowadays computer could, process this kind of information very fast. But it's not enough, because when you are trying to teach this model, or when you are trying to analyze something, you need far more speed. You can understand that particular idea, like in the beginning, I said, if you have a picture, you understand things faster, and because you focus on certain things. So we try to impart that same idea into these transformers. The transformers are they do work in the same manner. So they will try to look at the whole text as a picture. So they will try to focus on certain parts of it, and based on the word sequence, they will try to put like importance value. Okay, how much important this word is compared to the nearby words. And based on that, they will try to make connections. Okay, so these are the important words, and how these important words are connected to the neighborhood and to connect it to each other. These are like making connections, trying to understand something that is more complex, but trying to understand it, something in a very granular level. So then the next thing. So how this computer can decide which words are important and how they are connected. So it comes from the another human behavior. So of course, when we see a video, this is something another perspective of it. I would say, whatever I'm saying, but you never know that this is actually true in terms of mathematics. So if you're familiar with series, like mathematical series, what you need at least three consequent values to understand what kind of series it is. Is it arithmetic, geometric? What kind of series it is, right? So for video, it's a series of images, right? And text is a series of words, and music is a series of notes. So everything you can break down into in individual frames. For video, if you just break it down, what you will get series of images, right? And this, if you teach the transformer to understand one particular image, and then another. First, it will try to connect and understand the image first, image itself, and then it will try to understand this frame to the another frame. So for a human eye, when we see, so let's suppose you see the past. I'm giving you three different frames on the left. Can I? Let's see if I can get the pointer. No, it's not presentation mode, but maybe I'll try this not thing. Yeah. So if you see this three, then you can definitely understand what's going to happen next, right? That's the whole idea. So I will give you three frames, and then the last frame the computer can predict itself. So it's just like human behavior. If I know something is going to happen, and then I will know what is going to happen next. Like suppose you are driving a car and you know something fast is coming towards you. You will try to avoid. Why? Because you know the way the car is coming towards you. If you keep on the same track yourself, you will collide with the car. Everything happens in the same way. Every event in your life goes in the same path. If you're doing something, you know what's going to happen and what's going to be the end result, and that's how you decide how to avoid accidents. So that's good. I think we we could use this idea and try to do something else. So the idea I was talking about, let's try to use the same idea when we are trying to read about a text. So for the transformer are good at it is to keep attention to a text and then try to learn from it, right? I'm speaking same thing over and over again just to make sure that you get the idea of what I'm talking about, how it works. So it will not read the text word by word. Instead of that, it will try to find keywords within the text. And then it will assert importance of this particular word and how it is connected to the relevant other words. So just like the previous slide, what it could do is it will try to find this keyword like bag trick. Okay, plastic bag, that's kind of an important word, big number, or something similar. And then if you ask this model, okay, if you check a bag, you must use the clear plastic. What is the next word? It will automatically understand, okay, you definitely are talking about a bag because that's the keyword it has try to understand. Okay, this is something. So in the learning process, the more information you feed to this kind of model, the more intelligent it will be. But that's the price point of it. So if you try to teach any model with more data, is it possible it will react in the same way? There are two problem here. One, of course, the first one was the constraint of computational resources. So there could be a lot of computational power that is needed, and we didn't have it. Nowadays, I think we have enough. But the next constraint was it has to be fast enough to go through these texts. If it is not, then your model will be slow, and even if you ask something, the response will be again extreme slow. I will show you some of those things today as well as in demonstration, because that is quite important. Because if I'm saying everything to the slide, then it seems okay. These are the ideas, but can we do something? Yes, it is possible even with your computer. It might take quite a long time, but it will work. So that's the whole idea of it. So the GPT, it has evolved quite a long from GPT 1, 2, 3, 4. I think it exploded at 3 because it was quite fast and quite smart as well. But all of these models, they come with this parameters. We call it 110 million parameters, 1.5 billion parameters. So that's the model strength. So how many parameters it's being trained on, and based on different parameters, it could understand more complicated topic more easily and give you answer more realistic way without hallucinating on things. Now, I have used the word hallucinating. So what is hallucination? The thing is, these computer models, they are prone to answer things. That means if you're asking something, it is supposed to give you an answer. Now, if you are asking the computer about a topic which it doesn't have any understanding. That means this model has not been trained on this kind of data. Let's say I trained this model with clinical data, except cancer. And now I'm asking this model, okay, can you tell me what are the possible symptoms of skin cancer? It will give you answer, but that answer could be completely rubbish because it doesn't have understanding, and you're trying to ask it about it. Now you can find the same thing when you are experimenting on your students in the classroom. You know that that particular student, they haven't gone through the homework you have given, and you're asking, okay, answer me this. And there could be some students, they could be honest. Okay, they'll say, okay, I know, I didn't study, I don't know the question itself. But there are students who could answer you something, and you know that that's not the answer. And they do the same thing on the exams as well. They want to write something. So that's the idea. It's called hallucinating for computers, and for humans, they're being just smart. Okay. Teacher might not read whatever I'm writing. They could just give me marks because the teacher might be too tired examining 50 or 100 people's in a copy. But for computers, it's just a liability. Okay, because they're supposed to answer us. So you ask something, they will give you answer. That might not be true. That's called hallucination. And these earlier models, they used to hallucinate a lot because, of course, the amount of data is very limited, and the computer could understand the data in a very, very limited way. It could only understand text, and this text should have been formatted in a proper way. Otherwise, uh, it couldn't understand. But nowadays, these models are so smart. You could just give them, if in a snippet of text, they could understand what you were talking about, and they will just update their memory. That's the new thing. Computers now are having memories, not the hard disk or I know the RAM memory. It's a permanent memory, just like humans. Like you teach a child, okay, this is your name. You should remember it through your whole life. Okay, I give you something, and this is your name. So that's called a memory. Or okay, your father's name is this, your mother's name is this, your permanent address is this, and this small child will try to remember that. Then you will teach, okay, how to eat, what not to eat, how to work. So all of these things goes to the permanent memory. So this is what's the same thing we're trying with the computer models. We're training the models to have this permanent memory so that when you are asking something, it will try to process that information based on the permanent memory. And more parameters you put in, better they will react. So and less they will hallucinate. So that's the way it is. But there's the next question. Are they limitless? Of course not, but it could be. You need bigger, smarter, faster computers. That's one thing, always will be. We do have now, it started with CPUs. You heard about Intel or AMD. They're the CPU giants. Then came the GPU, and now it's called the one new thing is TPU, tensor processing unit. And there is something called AI computers nowadays. It's basically GPU computers with AI chips. That means they come with these models embedded into the CPU, into their processing unit itself. So these things are, of course, the newest development in the area. So you will have a lot more capacity to train this model with newer data faster. But there's always but. Do we have enough information formatted in a proper way? Because the world is getting crazier by the day. Uh, it's the same thing with this human. We used to read books, and we used to trust these books. Every one of us have gone through this training. The textbooks that you used to find in schools, we trusted them. Okay, that's the information. That it should be true. Okay, Newton's laws of motion. Okay, of course they are true. But nowadays, internet is full with misinformation as well. If you're trying to find something, okay, let's say like a very common practice. Okay, I can give you an example. So suppose you're searching whether this is a bad thing if a black cat crosses a road. What you'll do? You'll say, okay, this is rubbish. Some of you will no, this might be true because we are following it for so long. It's a bad luck if a black cat crosses the road in front of you. So you'll stay for a while. Either you will wait for someone else, or you just stay for a while and cross the road anyway because if someone else is not coming. But this has two things, right? If you trust this thing, you will follow that and you will say, okay, this is the true thing. And the other ones will say, no, this is not. I have done so many times, nothing bad has happened ever to me. So you have conflicting opinion, right? But for the computer, if you don't teach, or you are the person who believes that, okay, the black cat thing is a bad thing, you will teach the computer the bad information. And then the computer will trust you, okay, because you are the master. You said this is true, so I will consider this is true. And then whenever you ask, okay, can you tell me whether it's a bad thing? It will say, yeah, it is a bad thing. And then the next big thing, if you feed the computer the both information, so it's a conflict. It's just like the computer can't decide whether it's a good thing or a bad thing. So the earlier models, they used to say, okay, I don't know. But now the bigger models, they are capable of reasoning it with existing knowledge and other information backed by it. The bias is always to go with this scientific evidences. So since it's not limited, it could try to search the internet and find relevant knowledge that backs this particular information. If it finds, okay, there are like tens of scientific papers that says, okay, this is not true, you can anyway cross the road and nothing will happen. So they will, okay, I have this two information on how people perceives this kind of event, but I feel this should be it. There is no scientific backing that this is a bad thing. So that's how it is. It has more knowledge. So unless you feed the model with accurate knowledge, it could go into something else because that is also about statistics. If there are like 100 people and among that like 70% believes something bad and 30% who believes something should be good, it will go towards the 70% because it feels like, okay, there is a higher opinion on this particular bias. So maybe that's the one. But the computer scientists and all these LLM scientists, they are trying to teach the model to trust what it is peer reviewed, scientific, and it has a proper logic to something. So it's all about learning. But then comes to the next thing. If you think about it, I think you will all agree, but you might not entirely agree with me. The foundation model that we talk about computers or LLMs, it's also connected to how we human are are supposed to learn things. So that's why we have this schooling system, right? So your first 20 years of your life, you try to learn things as a standard, right? So some of you are from SMS board, some of you are from a CBSE board, some of you are from ICSE board, if I'm not wrong. So this board, they actually creates an entire curriculum to make you somewhat standardized, educated person, and that's the foundation of yours. And after that, whatever you learn, you're trying to learn it based on your foundation knowledge. I can give you a small example. So you learn about mathematics, like okay, arithmetic, about geometry and algebra, everything. But then you go to the higher education, education, and then you try to learn how to use those things in practical cases. But if you don't have this foundation knowledge, you can go further, and that's how the LLMs are as well. So every like uh, levels like GPT-2, GPT 3.5, GPT-4, GPT 4.0, everything is like a base model, and then you fine tune it with a specific knowledge. Then it becomes expert of some domain, just like us. Like I'm doing computational physics, so I have a background, in physics. So I'm going towards computational physics or plasma physics. So basically, I'm doing everything related to physics. And since the physics is also like a kind of culmination of everything like mathematics and math and computation and everything. So this is something I'm becoming like a domain expert. So but my foundation knowledge is like mathematics, physics, chemistry, whatever I've learned in school, and this is the same thing. So yes, that's how it is. So there is a limitation. You can't teach a model to learn everything, but at least you have some base models. You can try to teach them some particular domain knowledge, just like we are. Because this base model I'm talking about is, of course, everyone has a separate foundation knowledge. Like even we had the same kind of schooling, like foundation training that we had in school, but still we went into someone into science, someone into arts, someone into commerce. So these are like domain expert that we have become. So it's of course it's our interest because we human, we have our preferences. But for computers, so if we train every computer model with the same foundation model, then they will be interested in every topic in a similar way. So that's the difference, but the idea is entirely the same. So what are the examples that I could give you? So this fine tuning that I'm talking about, like becoming a subject leader for computers, they are quite impressive. If you're familiar with that name, Morgan Stanley, so they are basically a law firm, and what they did is use this GPT-4 to fine tune their data. So since they are a law firm, they have a lot of cases that they have owned or they have dealt with, and they fed all this law books, case studies, every information they had, and then they use this pre-trained model, the GPT-4, and they fine-tuned it, and they have tested this model. It and they said it performs better than any lawyer because it doesn't do mistake. It will follow all the cases, try to analyze it logically, and try to understand what should be the right direction. So this is they're using on a day-to-day basis to teach the new the newcomer or whoever is joining Morgan Stanley. So it has reduced their or workload a lot because now they could ask it about something and they don't have to rely on human memory. Okay, have we done something similar in the past? Something like that. This is one of the examples. Then there is MIT. They were working on this medical AI with John Hopkins. So they have created an enormous model which can understand medical information and try to understand and analyze new information. And it's working like wonder. I'm talking about this completely different topic, right? For academia, I think we have enough tools that we can rely on. How you could use it, I will show you, at the end of this talk. And these are really, really great. I will tell you, I'm not sure how, if you have enough funding or resources to get the paid models, but the free models are as good as possible. Like, you can just rely on them as well because they might be slow, they might be limited in terms of responses, but they are good. You should rely on it. And also for other topics like arts, commerce, any kind of topics that is not connected to computer science or science stream, they can use even their own language. Like you can ask it to answer in Assamese or Hindi or any language that you prefer. You can just ask it. It will give you reply in your language and with enough efficiency that you can just rely on this kind of tools. So that's kind of it. So the next part is, of course, can we develop one? So what are our options? So of course, you could go with one the top generative AI models that have been offered by OpenAI or Anthropic or Perplexity or Microsoft Copilot. But they are, of course, that comes with either paid subscription or maybe sometimes it's just the trial version or the free version. So you can just go either of those, but at least you can start. And I will recommend every one of you after the completion of this whole FDP, just try it yourself. It's so intuitive that you don't even have to ask anyone, how can I use it? Just ask it how to use the tool itself. Then it will tell you how to use it, the tool. So you don't need training on that. So what are the other options? Because it's not only I'm talking about how to use it. If someone is more interested, okay, I'm using it, but I really want to know, can I build one? Uh, this is, I don't want to say something very superficial that, okay, yeah, you can build one and build something like OpenAI or Perplexity, but I would say you can build one. And sufficiently good one, but not, of course, in their level because it will require huge computational resources. And this is not humanly possible, frankly speaking. You need a lot of manpower as well. So what are our options? At least you could learn, and then you can join one of those teams as an expert, and you can be part of the team. That's kind of a something that you can look into if you're interested. Otherwise, just start using these tools. So our options are this generative adversarial networks, GANs. They're very popular. There is another thing called RAG models that is now very popular. Then you have these variational encoders, autoencoders. That's also a smart one, but these are all basic, so it has extreme limitation. They can't be that smart, but they can be enough smart to give you something. Then the next thing was to use RNNs, recurrent neural networks, and with RNN you could also add this LSTM, long short term memory. So you can see this long short term memory. That means when it processes through the text, it could try to remember something from the text. And when you ask the next question, it will try to use that information prior and then try to answer one based on that. And then there is one of the base level GPT, which is free yet. It is called GPT-2. Frankly speaking, everyone started from GPT-2. This OpenAI, Anthropic, everyone started with GPT-2 because that was a free version that the people who were working in the beginning. It was an open source project, and then they could see the future and the amount of profit they could make out of it. So they just jump into something else. It's a business model. Nowadays, it was not. It was completely research and academic thing in the beginning. So for now, what I tried for this meeting at least, what I did, I built a web crawler. Do you know what is a web crawler? So this web crawler is basically capable of crawling website data. So if you take any website, put the URL in it, and it will go through the website itself and fetch all the text within itself. And then you can use this text to train a particular model. So I tried it with three of them. This RNN with LSTM, then GPT-2, and then GPT-4o. For GPT-4o, I'm using the API because it can't basically host offline. But there are other alternatives that you can go with, like Llama by Meta, and there are others too as well. I can't recall the names at the moment, but there are others. But for because the GPT-4 is quite smart, so I thought that okay, I will give you a demonstration. But I'm not using the Chat GPT. I'm using the API so that I can develop something, locally on my computer, and I could just try to test out this model. So I explained you the web crawler, right? Let me share my screen, and then we can just jump into it. Okay. So let me show you. So this is the web crawler I developed, and then I can give you a demo how it works. Let's say I want to run this web crawler for a website that I can choose. Let's say, yeah, maybe this Wikipedia page or something else. You can do anything. Then if I run this, okay, my bad. So it's asking me to put a URL. Let's say I can put this, or it's already there. I tried to put something in default, and then if I start, so see, now it's trying to crawl the website. So you can see the progress bar. Now it has fetched everything. And we can check that, what kind of information it has processed. Just one quick question. Can you see my entire screen, or is it too big? Or
No, we can
means,
see it. We can see
Yeah,
your
yeah.
screen.
We can see
Yeah.
it.
Okay. Can you read things that is on the screen?
Not completely, but like
Partly
few
visible,
words
right.
we can pick.
Okay, let me try to share a part of it. Then it will be easier. I think this should be easier.
Yeah, it's good now. It's good now.
Mhm.
It's good now.
Yeah, I have a very wide screen, so it's kind of difficult if you try to see. Okay, so just give me a couple of minutes. It will take time because I'm running things on my institute's computer, because it has to be a bit powerful, but still I believe that you can run the same models uh, with your own computers. It might take something, but okay, for some reason it's just crashing. Anyway, okay, let's stick with this. So just remember the process. So first you need to train the model, or take a pre-trained model like GPT, and then you fine tune the model with your own data. Like today, what I'm trying to do, I'm trying to use this Wikipedia page. I guess everyone is familiar with Wikipedia, right? So, you have this Wikipedia knowledge that you can read through, or you can use that knowledge backed into something like a pre-trained model and fine tune it, and then start asking questions. So based on the model, how good it is, you could ask complicated question and it could answer anyway. So I'm not trying. It's just okay. Yeah. So I have three things. One is this GPT-2 model, where I will use this text, that I crawled from the website, then train the model and then ask questions. Then I have the RNN model with LSTM that I said. I will train the model, then I can ask question. And then the last one is the OpenAI, where I could use the same text that I fetched from the website and just ask it questions. So let's do that. For today, I don't think I'll be able to show you this RNN with LSTM because I was running the model yesterday and it's still running. It's just at 50%. It usually takes a huge time. But for GPT-2 and GPT 4.0, I will be able to give you the demo. Let's try that. So let me give you another glance. So I'm teaching the model about artificial intelligence. Artificial intelligence is being trained on artificial intelligence theory, but of course it could be anything. So this is the text. So go through it. So as a person, if you go through it, it will learn something or skip something, but you will still get some ideas. And thus for the computer models, it's something more easy because they will try to understand everything. Now let's try to ask question because it's been trained already. So I could just use this GPT-2 prompt. Just remember, these models are extremely small. So this at least GPT-2. So if you ask it, it might not answer in a correct way, but you could see how it's trying to understand. So for here, it's asking me to put a seed text. So what is seed text? This is something when you ask questions to a trained model, and it will try to use that text as a seed. So let me go through the website and find something that I can ask. Okay, see, I can see the goals. Okay, I could ask what are the goals of an artificial intelligence? What are the goals? Just let me know if you don't see it clearly. I can just make it bigger.
So, okay, but it will be better if you make it little bigger, little bigger.
Okay, this is fine.
Yeah, this fine now. This fine.
So now I'm asking question, and the model is using this text to generate response. So see, it has created 5 responses. Just remember, this is a model that I trained on my computer. So very small, and the answer could be like, a bit mixed up hallucination, bit mixed up here and there. So I asked, what are the goals of artificial intelligence? So it says the first response is, in general, there are 2 different things, but they can have both the same effect on society. They facilitate the pursuit of goals that humans have typically been unable to achieve. See, I fed it the whole information, this whole page, and now it can answer. And it's not OpenAI or ChatGPT or anything. It's something that we built and it can build as well. And it's trying to answer. It has given me 5 responses. maybe the 5 of them are not so bad. Maybe we can try to understand. Okay, the first one is not bad, of course. The second one is what it is. The second one is really bad because it's asking me a question when I'm already asking. It's a question. It's like answering a question with a question. That's really bad. What about the next one? Despite the enormous push in 1990s for machine learning and deep learning, the field has been unable to find general, elegant, and traceable methods for solving often multiple step problems. So this is kind of like a shortcomings it's trying to present. So it's not an entire answer, but it could be something like a part answer. The fourth one is equally bad. Fifth one is okay. The potential applications of machine intelligence are enormous. They include intelligence, robotics that move objects, autonomous vehicles, autonomous information gathering and control, surveillance, and disaster management. That I could say it's a good answer. So it's trying to answer 5 responses to my question, and they are not that bad, right? So that's one of my example. You can ask anything else. Let's say we go to the web page again and find another. Okay, what is local search? I can ask this, right? What is local search? Okay, so it's trying to give me another 5 responses. So we define search as the process of finding a value by observing changes in a data set over time. That's not bad. But the next one is saying methodological structure of natural language processing is usually represented a tree or set of nodes represented by nodes. Yeah, still okay. So this is something I'm trying to say. So this is a very basic model, and it already can answer at least better than us, because we couldn't read this text so fast and give you some answer. So let's try the next one. This one is super smart because I'm using a trillion parameter model. Let's say, okay, okay, this is my bad. Let me just. It seems I didn't set them all. Okay, let's see. Okay, I can ask the same question. Goals. Shells. Just ignore the comments because the text I'm feeding is too long, but it will give you answer. See, now it's giving me proper answer. These are not 8 responses. So it's trying to answer the question with, bullet points. So it says, okay, the goals are reasoning and problem solving, knowledge representation, planning and decision making, learning, all of this. So that's a good answer. I could also ask the same question: what is local search and AI? Yeah, now it's talking about local search. Starts with a guess. Local search begins with an initial solution or guess and works iteratively to improve it. Then neighborhood exploration, hill climbing, simulated annealing, gradient descent, and evaluation algorithms, and swarm intelligence. So you can see how intelligent it is. So it's trying to process the information that I provided. That's the text from the Wikipedia. And it's also adding its own understanding about the topic from previous knowledge. So that's how it is. But streamer. Everything is happening on your computer just through an API for this one, but the other one was completely local. Okay, now we'll exit from this and let's see what else we can talk about. So now you see that there's something that we could do at our level, how to build something like that and how to work with it. So the way I designed these models are the following. So we used a web crawler to generate this text, and then we use this text to train the model. And this model can be saved locally. And then we will use a prompt generator that I was using to ask this model about specific questions. And you will get your answer. Now, if you're interested to play with a model or maybe learn how to develop such models, this is within our institute's GitLab repository. But I was planning to put it on open web like GitHub. And if you are interested, you could send me an email and I could share you the link where to find these models and how you could start. Because this models and the code that I developed is very easy to pick, and you can just start there. So what else we could do this kind of with LLMs and generative AI? Nowadays, it's not limited into just text, because what I showed is just the text ones. Now it could understand text, images, speech, structured data, 3D signals, so all of it. And they are baked into one foundation model. So this one foundation model could answer you anything about this kind of information, because it's not only going one thing at a time, like only text or only images. It can go for multiple things and try to build a knowledge out of it. So this is very, very fascinating, because now you know that when we are trying to understand and assess, it could be it could not be something like only one text document. Like if you're reading a book, or you're also watching a YouTube video on that very particular topic, and you are discussing the same topic with your colleague. And at the end of the day, you have one understanding. It's not like, okay, I will answer you only from the YouTube videos or only from the discussion or only from the text that I read. So this is the way humans process intelligence and try to develop understanding on certain topics. So these foundation models are being adapted to do several different tasks, like question answering, the one that we did, sentiment analysis, the one that I talked in the beginning, like can it understand what you are talking? Okay, with are you asking me to do something, or are you telling me something? Or are you angry that because I'm unable to do certain things? So this kind of things it can understand. Information extraction. This is something also we did with question answering. Like you have a huge text, but you could ask specific question to extract specific information. Image captioning, that is possible. Now, when we post something to social media like Facebook or Instagram, you try to come up with a caption based on what you see in the images. You can do that automatically nowadays with with the tools. Then object recognition. So this is nowadays very popular with this live feeds and the cameras mounted on dashboards. It could try to understand what is going on around, and it could actually help help to develop better autonomous vehicles. This is one of the things that we do at our institute as well. And then following instruction. That means suppose you want to solve a specific problem, you could try to write down, okay, this is the way I solve it. Can you use the same method? Then the model will follow exactly the same method and try to do this. And then if it fails, nowadays the models are so smart, it will tell you, okay, the method you gave me is okay, but I have something better. I can improve the methodology. That's one more thing. And so what all of these task capabilities are helping us to build better foundation models and do higher complex tasks like vision task or higher order tasks. You can know more about these things, of course. Always just take note and visit this. Now this ends the topic that I was talking about, the generative AI and LLMs. But I guess you have at least some understanding about the LLMs and generative AI in general. I could give you a few more examples of how you can use it in your day-to-day life. Let me go to things that I do use. Um, so these are the three tools I use a lot. You could use something else, but I think this is a good start. So what can I do? There are certain things for everyone. You can ask questions and expect answer that you could use in your day-to-day work. Let's say I think I'm asking this very stupid questions. So can you tell me something interesting about mm, mm, just a basic question. See, now I want to ask it, can you tell me everything you said in SMS? Let's see. Sorry. So let's see. So it can ask things that you want to know about. And you can ask it in your language as much as you want, and you can ask a follow-up question. So what I can do next is tell me more about, okay, and it will tell you. And then you can ask further question, more deep, more deep, more deep. And there is no end of it. So you can just try as much as possible. So this is one of the examples. Perplexity. So this will go on. You can just try these things. This is just one thing. You could ask scientific questions, the topic you want to teach to your students, the way you want to teach it. Like suppose you want suggestions. Okay, I want to teach about artificial intelligence to my students who are doing bachelor or who are class 12, class 11 students. So can I explain them with the basic information possible? So it will try to give you a guideline how we can explain these topics to them. Or if you want to pick a topic that you are planning to teach, like day-to-day physics knowledge. Okay, can you explain me, laws of motion? Can you explain it to me like a 5 years old? Everything is possible. These models are trained to do the such topic. Plus perplexity is something similar, but it's more robust in terms of getting online information because ChatGPTs they are trained with an older date. So any information or any current affairs you want to ask ChatGPT, sometimes it might not work. Now there is another option. It's called Let me share. If this web one, so it could bring the web results as well, but still it's limited. Perplexity is much better than that. So if you want to work on a research paper, and if you want to understand, okay, let's say can you give me latest information and research on artificial intelligence. Okay, let's say. So it will give you answer and also cite sources. It could be research paper, it could be news articles, it could be websites that has this information. So it will see this kind of footnotes like one. So and you can click here and you can go to this particular website to actually get this information. So this actually restricts the models to hallucinate less. So you have more control over what information you're getting. Anthropic is exactly the same tool, but it has some capabilities better than others. Okay, so I think I should stop here and let you give the opportunity to ask questions if you have any. I'll be happy to answer, but it's entirely on you, whatever you want to ask. I
Yes,
can
sir.
ask any language, so I can understand as well. So don't.
Yes, sir. Thank you. Thank you for your nice talk.
Yeah.
Sir, am I audible?
Yes,
Is
you're
my
audible.
voice is audible?
Yes, you're audible.
Okay, okay. Thank you for your nice talk. You have explained very well about large language model. Large language, what I have understood is that I am layman to this field. Although I am from mathematics background, but I am layman to this field. What I have understood from your talk is that large language model are tools. These are basically AI tools who can think like like human being, who can understand. You are trying to impose human thinking, analyzing, summarizing all these powers to AI tools, and these are called
Yeah.
large language models. So it
Yes,
was very
exactly.
nice talk. I'm very much thankful to you, and we have some questions actually.
Yeah,
Uh,
sure.
our participants has some questions to you. The first participants, Dr. Dhurvajyoti Soikia, has asked you one question, that is, how quantum computer can be used for artificial intelligence?
Yeah, this is something that is happening at the moment. It's not imagination anymore. We do have quantum computers, and for that, of course, it's faster, right? And from the beginning, I'm saying you need a faster and more powerful computers to build better models, to build better foundation models. So quantum computers, in terms of working principle, it doesn't matter because the logic that you need to build these models are always same. But the quantum computers are quantum computers. How it operates, it doesn't restrict you to build to build a different model or something. So this is just more powerful computer doing the same thing. So of course, if you are an expert or if you're looking into quantum computers as a research, or as a future, I would say just go for it because the next step is that, and people have already started working on quantum computers to build large language models because this could be really good.
Okay, okay. We have another question from
Hmm.
Pubanita Huya. She asks, if one writes an article using ChatGPT, can plagiarism softwares detect it?
Not the regular one. I know that if more of you might have done this thing while submitting an PhD thesis, we go through this plagiarism check. It will not work on AI written articles, but there are AI tools that can detect. There is one called GPT-0. I can give you that. GPT, like, let's see, I can have it or not. There is GPT-0, Zero GPT. There are like a lot of different tools. I can show you.
Please share your screen, sir, so
Yeah,
that we
I'm
can
trying.
see.
Yeah. Okay, so this is GPT-0. You can copy paste whatever you have received. Let's say I'm not sure how good it will be, but I will try. So let's say I'm just copying something from here and putting it here. Sorry. This. Okay, so I pasted the text and I asked it, can you check if it's written by AI or something? Same thing I can do it here as well, detect text. It will tell me. So it says this GPT is 0%. That means it can actually tell you whether it's written by GPT. Of course, I'm copy pasting something from Wikipedia. That's human written. So it's not GPT written. So it can understand that. I can see here it says probability 1% AI generated. See, this is quite accurate. So this is one of the examples. So you can use either GPT-0 or this zerogpt.com. And there are several other options, but I think I usually use this kind of tools.
Okay, thank you, sir. And we have one more question. Dr. Gunjan Sharma raised this question. He writes, thank you, Sanda, for your talk. I think he knows you. Can we use this tool or build a personalized mode to analyze data? For example, data we receive from a Langmuir probe.
Yeah,
this is
Langmuir probe. He'll understand.
this is possible. Not with GPT-2, by the way, or the basic models, but the higher models, the more complex one, like this GPT 4.0 or anything further, 3.5 is fine. Just train it and ask it what it's. Eventually, I think you don't even have to build this model. You just upload your CSV data or Excel data. It's not only for language probe. I'm telling you, like suppose if you have some data for the for academic purpose or administration purpose, you can just upload it to this tools like ChatGPT or Anthropic or Perplexity. It could process the data and plot the data and create graphs, create presentations for you. So this is entirely possible. A language probe is far more simpler. And with the advanced model, I do think it's already been trained on the electrical signals.
Okay, thank you, sir. There are some comments like nice presentation, nice presentation. Thank you, sir. Thank you, sir. Very nice presentation. And now Parthada is showing you a token of love that we are offering to you. Thank you so much for joining us and
Thank you.
providing us a very nice talk. And it will be definitely help our young researchers and our faculty members also. And they will give new insight in the research field. And I am also very much thankful to you. And this is very new to me actually. I do not know about large language model, but after your talk, I have few idea. I have gained few idea about what these are the things. Okay, thank you for all these things. Thank you.
Thank you, Sayan, for your nice talk. I mean, you have presented a very complex topic in a very simplified manner. I think if the participants are giving their attention, I am fully confident that they have learned so many new things today, especially how the artificial intelligence works in its core. I mean, that's a very nice talk, and I'm very happy that you have presented it in such a beautiful way. Thank you so much.
Thank you. That was the main aim of it. But I think just to end everything, go there to these tools and try something by yourself. It could be extremely dumb, but try it. Once you try it, you will attach to it.
Okay.
use these things on instead of like just doing Google search. It's far more efficient, far better, and it's actually an excellent tool to learn new knowledge. So we have made such a complex and such an intelligent thing nowadays, which is accessible to everyone. That now these tools can be a good teacher. So yeah, just go for it.
Okay. Okay, sir. Thank you. Then we will conclude this session. I request the
Okay.
participants kindly fill up the feedback form. It is given in the chat box. Okay. Thank you.
Okay. Bye bye.
Thank you.
Bye
Bye
bye.
bye.